My name is Reising. I'm a sophomore here at Wazoo studying mechanical engineering, and I work at the HYPER lab. I'm on the HYPER-Borea team where we're using liquid nitrogen with the lead-in frost effect to explore the mitigation of lunar dust on spacesuits. So as all of you guys know, we use liquid nitrogen for HYPER-Borea. So before we get started on the training, I do want to hear from you guys. Oh yeah. Where have you heard of liquid nitrogen before? In industries, what ways it can be used? Just shout it out.
Medical industry?
Yes. Yep. Food industry, definitely.
Transportation?
Yes, for sure.
Ice cream!
That's...
Different dots.
There's also a company called Sub-Zero that uses it.
Yep, yeah. I think I've heard of that. Yeah, dermatology is another one. Probably heard of that. And of course, research. So that's a big one. So obviously LN2 is used in a lot of different places. And while it can be super cool, it can be dangerous too. So it's important to learn how to handle it safely right off the bat. So I made some worksheets, if you guys want to pass those around, just to follow along. But first things first, what is liquid nitrogen? Liquid nitrogen is a cryogenic liquid, and it's at the temperature of negative 210 to negative 196 degrees Celsius at normal atmospheric pressure. And there are three big safety hazards, thank you, when it comes to LN2. And I'm calling those the 3 Bs. We got burns, bursts, and breaths. So you'll see those on your worksheet. We're gonna start off with burns. So everyone here, I think, has heard PPE. Personal protective equipment is definitely the first thing you want to think about when it comes to handling LN2. The big takeaway is you want non-wicking clothing. So you don't want the LN2 to be caught anywhere and held against your skin, because that's what leads to a cold burn. So for example, we want pants untucked from shoes. So skinny jeans are not a good example. Shirt untucked from your pants, that kind of thing. And then you also want to observe the normal lab safety, so hair tied back, no long jewelry, that kind of thing. Safety glasses or a face shield, which everyone here has. And then finally, you want to think about your shoes. So leather boots or other waterproof shoes are top choice. And things like tennis shoes or things that can absorb liquid are not great. And we're gonna do a demo to show you guys why. So I have here a tennis shoe, and then I think we've got a leather boot over here. So yeah, if you guys want to move a little closer to look, you can. Of course, observing social distancing. Okay. How do you bring out thing? Okay, so what we're going to be doing is we have a thermocouple here, which is going to measure the temperature inside the shoe. And I am going to pour liquid nitrogen on both of these shoes. And if you can see it, I want you guys to pay attention to the temperature difference between the shoes.
You should probably rerun this when I'm out of the...
Okay, yeah. Yeah, we can do as many reshoots as we need. All right. So another personal protective equipment, when you're handling the liquid nitrogen, you want these thermal gloves. Okay, and here we go. And always be sure to cap it. Okay, so I've got my LN2, and I'm gonna pour it on the tennis shoe first, and then the boot. And you guys see the temperature difference there? You guys see it okay? All right, so if you can see it, the temperature in the tennis shoe went way down. So it's super, super cold in there. And the boot had barely a temperature difference. So that is showing that if you were wearing tennis shoes while handling liquid nitrogen, and let's say some of it spilled, your foot could potentially have a burn, or it would at least hurt really bad. So we don't want that. And in conclusion with that, always wear leather boots or waterproof shoes. All right, so the next,
Let's get this out of your way.
yeah.
You got down to 95 Kelvin in the tank.
The next way you can burn yourself with LN2 is a hot burn. And I know this sounds kind of weird, but if you are using LN2, you can actually produce liquid oxygen. And when liquid oxygen comes into contact,
liquid air.
Oh, liquid
Not
air.
oxygen.
Liquid air.
Air has liquid oxygen in it.
Okay, yes. When liquid air comes into contact with a combustible surface, it can create a fire, which of course can cause burns. So I'm gonna do a quick demo just to show you guys what the liquid air looks like. So I've got my metal flask. Okay. So this is gonna be kind of hard to see from far away, but there's a little line forming here, and soon you'll be able to start seeing some drops come off the side. There we go. See those drops? So that is the liquid air. Now let's say you were outside on a hot day. If that were to come in contact with the hot pavement, it could actually combust and start a fire. So always be aware of where you are handling your liquid nitrogen and where the liquid air is going. Yeah, all right, so key takeaway from our first B, burns. Remember to never wear clothing or shoes that can catch the liquid nitrogen. And remember to always be careful where you're using liquid nitrogen so that the liquid air doesn't come into contact with it.
Lauren, talk about the gloves that you're wearing.
Oh, yes.
Did you show the gloves and the
Yes.
safety goggles?
Yeah.
Did you explain why we always wear safety goggles with LN2?
You don't want LN2 in your eyes.
The droplets will literally freeze the outer layer of your eye, leaving a gray spot. That'll take a while for your eye to grow over. And so that's another place where the LN2 can get caught in your body, is your eyes, your mouth,
Right.
your ears. Okay, we never want liquid nitrogen getting trapped somewhere where it can't push itself away from us.
Yeah.
Okay? And so a demo I'm going to do here for you.
Go for it. If you want to come to this side, you do that.
To show you how powerful liquid nitrogen is trying to get away from you, and that the key is just not trapping it against you. I'm filling this Pyrex vacuum flask here with liquid nitrogen. We'll just let it cool off here. Okay. And it'll settle down as soon as it chills down that innermost layer of the Pyrex. And so, yep, here it's settling down there. It's starting to. Just give it a second. It'll finish getting it cold. See, now the bubbling's starting to flow down. Okay? Liquid nitrogen is so cold and everything around it is so hot that it forms a vapor layer whenever it's in contact with something very hot. And so what that vapor layer does is it insulates something and pushes the liquid away from it. So much so that I can take my bare fingers and I can just, without getting burned. And if we did that really close up with the video, you'd see that around my fingers a vapor bubble forms that insulates it and protects it. Which means that as long as the liquid can just roll off and not get stuck or trapped, we're going to be safe that way. For those hand-down takeaway.
Thank you. Oh, yeah. All right. There's a lot in there now.
first time I ever did this, I knew math and I knew physics, but I hadn't practiced it because I didn't have time. So I did it live on video in front of the class.
Oh my gosh.
Anytime.
All right. Any volunteers to go first? Here you go.
Don't. I mean, 3 seconds would be enough. Yeah. Oh yeah, I forgot it makes your hand feel wet.
Yeah.
But you would have 2 seconds.
Yeah, I forgot it makes
There's a boundary between the quick.
Go 1001 out. Makes your hand
It is
feel
a
wet. I
weird
forgot about
feeling,
that.
yeah.
Or wet. Isn't that interesting? Yeah, a lot of people commenting on it. It's like punching a cloud is the other thing people comment on.
Oh, the punching a real cloud wouldn't feel anything like that.
No.
Yeah.
No, what?
Yeah.
Ruining the
Punch a clown and how it doesn't feel like.
That's weird.
You know what? Might as
See what I mean? It
well,
kind of
yeah.
it's like
Very
it's like a wetness feeling.
Oh my gosh.
I think my favorite demo though was still when you asked
I know,
why
this
is
is so
with like the marshmallows when it put the steam and the kid was just like, because you're a
So that concludes our first B. If you guys have any questions or anything before we move on, now's the time.
So besides like hot pavement, what other areas do you want to avoid? Because like the wooden table is combustible,
Yeah.
the paper's combustible. So where is it okay and where is it not?
You know, that is a good question.
Hydrocarbons, I mean, obviously they react strongly with oxygen. Wood reacts moderately with oxygen. Okay, so if you're concentrating hydrocarbons with volatile vapors over like an asphalt or freshly laid asphalt, that would obviously be a big issue. The first guy to liquefy air, Carl von Lindy, had oily rags from his liquefier that liquid air had condensed on. And one day somebody just grabbed one of the rags and threw it. The rag that was soaked with liquid air hit the wall and exploded. Okay? So like it literally blew up. Didn't catch fire. Kabam! Exploded. And that was when they realized for the first time that liquid air was concentrated oxygen and very dangerous. Because it had hydrocarbons soaked in a matrix with that condensed liquid air.
All right. Yeah, good question. Any other questions? All right. Now with this section, I could talk about it a lot, but it's going to be a lot more helpful to understand it once we do the demo. So I am going to give a couple quick facts before we do the demo for this one. Liquid nitrogen, when it's expanding from the normal temperature to room temperature, it actually occupies a volume which is 703.6 times larger than the liquid state. And then another thing is, if you were to fill a container completely full with liquid nitrogen and let it boil to room temperature, it can actually reach a pressure of, I think the number is 42,196 psia, which is a really big number. So to demonstrate this, we have a pretty cool demo lined up. Which,
I'll do the first. You do the
yes,
second.
sounds good.
Okay.
Okay, I'm going to come right over here this side. You can get this side. All right. Now we're going to go right for there. All right. Now notice, this was done not ad hoc. I have lots of experience doing this. All right. You don't hold on to it any longer than you have to. All right. Ready? Yeah. You might need your ears plugged or one plug. Probably not. Okay. Here we go. If you get one that's too thick and you don't get it full enough of liquid nitrogen, you run into a very dangerous situation that you should not mess around with here in the lab. Because I don't want any calls saying, we created a pipe bomb on accident in the lab and we don't know when it's going to go.
Here we go.
Don't hang on to it any longer than you need to.
Okay. Key takeaway from this section, like Jake mentioned earlier, you never want to store LN2 in a container where pressure can build up. Okay. All right, awesome. Okay, you guys, any questions before we move on to the last section? Anything so far? Okay, cool. All right, so the third and last B is breaths. So in this section, we're going to be talking about asphyxiation. Who here has heard that word before? Okay, that's what I was thinking, everyone here. So asphyxiation is one of the big hazards when it comes to any cryogenic liquid, but especially LN2. Asphyxiation is the displacement of oxygen in air, and it can lead to suffocation. So it's a super important thing to think about. To demo asphyxiation, we just got some new oxygen monitors, and so we're going to use this to show you how it monitors the oxygen levels. So here we go. This is our O2 monitor, and this one's awesome because it's going to flash some lights, make a really loud noise, and vibrate if there's not enough oxygen in the air. So what I'm going to do is hold it over this liquid nitrogen, and we'll see what happens.
Attention please.
Oh.
Oxygen gas.
There we go.
Low concentration.
Okay. Just got it. There we go. Now it's back to normal. So this thing is awesome. The reason why it went off right here is because right above the LN2, the oxygen levels are super low. So as Greg told me earlier, if you were to put your head over this and take a deep breath, you would probably pass out, which you don't want to do. And that's an example of asphyxiation, which can be very dangerous. So always make sure you use an O2 monitor and be safe.
So
Yeah.
it's because, so imagine multiplying that, do the math and multiply that little container of liquid nitrogen by 703.
Ooh.
And when that boils away, that's how much it's going to displace. And so that, honestly, something that small, I mean, you'd be, about 25 times, or 300, or 35 times 20, make 700. So 35 of those over, 20 over that high, that's how much oxygen you would displace.
Wow.
So that gives you a quick way to do the math to figure out exactly how big of an area you need to be worried about. Now the issue, why this is a serious concern, is can you tell that that's nitrogen in there, Lauren?
No.
I mean, it's a colorless, odorless, tasteless gas, right?
Yeah.
You have no idea you're breathing out all of your oxygen and breathing in a full load of nitrogen. It's not like going underwater where you can't breathe. Because there, you've held your breath. In this instance, you don't even realize you're running out of air. You just face down. Okay. So you won't even realize that you're running out of oxygen if it's a real oxygen-deprived environment. You'll just breathe in the full load of nitrogen and just be down. And so that's why it's so dangerous, and you need to be careful about asphyxiation risks in a situation like that. And so at Berkeley, they had one of these big doers. Somebody was trying to take it across a grassy area, and it slipped, and it rolled down to the bottom of the stairwell and burst open at the bottom of the stairs. And so people were trying to come in there to be heroes to try to stop it and tip it back upright and everything. Imagine all of that in the bottom of the stairwell. That could displace all the oxygen in there real quickly. You're not a hero if you're face down in that, having to be saved by somebody else. And so this is a very real thing that people continually run into problems with all the time. 6 people died in Georgia earlier in February at a chicken packing plant that uses liquid nitrogen to freeze the chickens. A pipe burst flooded the area with liquid nitrogen. Nobody had an oxygen monitor. Several people went running in to try to grab the people. Stop it. Okay, so that's why the O2 monitor, if you're ever in a small space, will really make a difference.
Yeah, definitely. Yeah, so I guess key takeaway from that is never use LN2 in an enclosed space where there's no airflow or anything, because that's what leads to asphyxiation. Well, that concludes our training today. Remember, next time you're using LN2, the 3 Bs. Do you guys want to say them with me? Burns, bursts, and breaths. All right, awesome. Thank you guys.